Hi guys, so this is part 2 of Ashley and I's final project for Engineering 305. My name is Danica and I'm going to be walking you through this part of our project. For this part of our project, we were required to design a data mining system that would improve a business system, and many large businesses want to compare similar retail locations or manufacturing facilities that they have to see which of those locations are high performers and if there's any techniques that those high performers have that they can implement into their lower performers. However, a lot of these locations differ based on what city they're in, the size of the location, how many employees that location has, the type of equipment, how much equipment they have, how new the equipment is, the management of the facility, etc. And because these locations can differ in so many different ways, it's not fair to compare all locations to one another. So we can use a k-means clustering algorithm to group these locations into fair groups. For example, it wouldn't be fair for us to compare a location in New York City to a location in a small town like Lynchburg. If we were to use a k-means clustering algorithm on these facilities, most likely New York City would be grouped in a different cluster than Lynchburg. So to put this data mining system to use, we came up with an example scenario. We are going to pretend that there is a company that manufactures cars and they have facilities all around the United States. And each of those facilities has different amounts of employees and machinery. And we're going to use a k-means clustering algorithm in MATLAB to group each of these manufacturing facilities so that they can be fairly compared. So let's quickly look at some of our data that we came up with. This is notional data. It's theoretical data per se. So here you can see that each of the facilities is listed and the number of employees that work at that facility, the number of machines that facility has, and the number of cars that are manufactured at that facility every year. So when we graph that information on a plot, the number of employees by the number of machines, it looks something like this. And we're going to use the k-means clustering algorithm to find different groups within this plot. So the first thing that we need to figure out is how many clusters we should use, like how many groups should there be. So this code over on the left is our MATLAB code, and really quick, just running you through it, the X, Y, and Z variables are just loading in the data that I showed you on the previous screen. And then the RNG default is just allowing it to be used over and over again. And then these IDX3, IDX4, IDX5, that's where the actual k-means clustering is occurring. So the k-means, in parentheses, you see the Z, and that's our data. And the 3, 4, and 5 represent how many clusters we're testing. So on the right, you can see each of those graphs that we created. The first one up in the top left is 3 clusters. The one to the right of that is 5 clusters, and the one on the bottom is 4 clusters. Now, the higher the silhouette value, the better that clustering group is going to be. So when we take a quick look at these, we can see that group 4, or a cluster of 4, the one on the bottom, is actually going to be the best bet. However, if we want to quantify this, we can actually use the average silhouette value. And we can see here that cluster 4 is the best one to use. So now that we know that we need 4 groups, we need to find where those clusters actually are. So this first part of our code is just loading in the data once again. The first IDX that you're seeing here is representing which cluster each data set is going to be assigned to. And then the IDX, C is figuring out where the centroid for each cluster is. This next group of code is basically graphing the previous code. So I won't walk through this in detail, but the important stuff is that this is going to graph each point in its respective cluster, and then it's also going to mark the centroid of each cluster. So here we can see that graph. We have 4 groups, just like we calculated we would need. And there's 4 different clusters in 4 different colors, so you can easily see where those clusters are. And then the 4 big black X's are the centroids for each of those clusters. That's all fine and dandy. But it would be super helpful if we could see the boundaries of those clusters so that if we were going to predict a future factory, we would be able to figure out which cluster it would belong in. So all this code on the side is just to basically put boundaries on the plot that we saw before. And it looks something like this. So here we can actually see the boundaries of each of those clusters, and we can use this to forecast what a future factory might fall into. So we've seen how k-means clustering can be used in MATLAB, but it still doesn't answer our problem statement. We want to know how we can use this information to compare locations that are similar. So this data you're seeing here is just a random sample of the data once it's been assigned to a cluster. But let's say we wanted to look at all of the data for cluster 4. We can filter the data so that we find all of the locations for cluster 4. And then we can graph that to see what their output is. So the output for each of these manufacturing locations is how many cars they manufacture in a year. So you can see here on the bar graph that the blue bars, those are some of our better locations. They're manufacturing the most cars. The peach locations are doing okay, like they're definitely manufacturing a high amount. The purple bars are kind of our average, or maybe getting even a little bit below average. And the green bars are areas that probably need some improvement. So what we would do with this information is do an analysis on the Seattle and Jacksonville locations to see if there's anything in that data that would suggest why they're doing so much better than the other locations, and seeing if we can implement any of those strategies into the green locations like New York City or Boston. So really briefly, in conclusion, just some last thoughts for you. Data mining systems can be useful for many business types, from the small business all the way to the Fortune 500. For me personally, I have seen similar algorithms used at Fortune 500 companies, specifically when comparing retail locations to compare similar workloads. Some quick lessons learned. There's a lot of different data mining algorithms out there, and it's definitely worth looking into and educating yourself on those. Another lesson learned is that MATLAB and Excel can be extremely useful. Doing a lot of this data analysis by hand would be extremely difficult, so I guess I'm just thankful that those programs exist. So I hope you enjoyed our video. I hope it was useful, and I hope it sparked your interest for data mining.